We're often going to have two or more functions interacting with each other. In this lecture, we'll explore the fundamental ways functions can interact with each other. And the way they interact is called the composition of functions. The notion of composition of function is that we're going to use the output of one function as an input of another function. Let's look at a specific example to illustrate on this idea. The problem statement says that we are given three functions, f of x, g of x, and h of x. What is the domain of this composite function and that of, meaning the domain of these composite functions? So we want to compose this function using these three functions. Now let's focus on the first case. F over g composed with h. What is f over g? F over g is an arithmetic composition that says f over g of x is equal to f of g divided by g of x. Now this g of x cannot be 0. In our case, it's not 0, it's 2x. G of x is 2x. So we can replace this and we can replace f of x with x plus 1. Great. Now we understand what f over g means in this composition. Now we want to compose this with h. Now this notation f over g composed with h means exactly the same as this notation f over g of h of x. We're going to use this notation because it's much more convenient to follow. So we're going to focus on the innermost function, which is h of x. So we're going to replace h of x with square root of x plus 1. So square root of x plus 1. Now this function, f over g, is this function. And we got f over g of x is equal to x plus 1 divided by 2x. We'll replace x with square root of x plus 1. So we have square root of x plus 1. We'll just plug this in and we're going to get this out of this. In case of x, we're going to have square root of x plus 1. Now, we want to find out the domain. But to find out the domain, the important question you should be asking is that what can go in without breaking the function? Now, square root breaks when negative inside of it. We have square root in this function. So we cannot have any negative value inside this square root. So the function will, square root of x plus 1 breaks for any value which is smaller than 0, meaning any negative value inside of it, inside of this square root will break the function, will cause it to break the function. Now we subtract 1 from both sides and then we're going to get x less than minus 1. So for any value smaller than negative 1, this function will break. Another way this function can break if the denominator is equal to 0. In the denominator we have 2 times square root of x plus 1. Now this breaks, the function breaks for 2 times square root of x plus 1 when this quantity is equal to 0. Now with a little bit of algebraic manipulation, we're gonna get x equal to minus 1. Now for the value x equal to minus 1 and for any value smaller than minus 1 will cause this function to break. So either way the function can break. Now combining these two, we can find the function fails if x less than or equal to minus 1. So we're going to combine these two conditions and any value smaller than minus 1 or equal to minus 1 will cause this function to fail. Now to find out the domain, we have to avoid these values, all these values. So we're going to find the opposite statement of that. The opposite of that is any value greater than -1. So we're going to exclude all these values. We're going to accept the values greater than -1. So that would be our domain for this function, for this composite function. Now we're going to focus on the other composite function. So the other composite function, let's try to compose the function first. H composed with G composed with F is the equivalent notation H of G of f of x. So we're going to focus on the innermost function, f of x. In place of f of x, we're going to write x plus 1. So we have x plus 1. Now the innermost function at this moment is g of x plus 1. Now what is g of x plus 1? It's 2x. So in place of 2x, we're going to replace x with x plus 1. So we have 2x instead of x, we have x plus 1. So 2 times x plus 1. Now we're going to multiply it through with 2. 2x plus 2. Now the only function that we're left with is h. What is h? H is square root of x plus 1. Now in place of x, we have 2x plus 2. So we're going to replace x with 2x plus 2. So in place of x here, we have 2x plus 2 plus 1. So plus 1. Square root of 2x plus 2 plus 1. We're going to take out this parenthesis and we're going to add these two integers. So we're going to left with square root of 2x plus 3. This is the composite function we have constructed. Now we have to find out the domain. Again, we have to ask what can take in without breaking this function. What values this function can take in. Now we have square root, and we know that square root breaks when negative inside. So to find out the domain, we see that the square root of 2x plus 3 breaks for any negative value inside. So 2x plus 3 smaller than 0, which is alright. So any value smaller than 0 is negative. Now with a little bit of algebraic manipulation, we're gonna end up with x smaller than minus 3 over 2. So any value smaller than this number will cause this function to break. We have to avoid this. So basically the function fails if x is smaller than minus 3 over 2. So since all these values cause the function to fail, we have to avoid those values. So we have to find the opposite statement of this to find out the domain, which are the acceptable values. Therefore, the domain would be the opposite of this statement, x greater than or equal to minus 3 over 2. These are the values we can accept, and we're going to exclude these values from our domain. Now that we have found out the composition of these two functions, along with finding their domains, I want to remind you an important piece of information about composition of functions. The order is important when we are composing with two or more functions. For example, f of g of x is not equal to g of f of x for the most case. So the order of composition is massively important.